For my group assignment, I tried to categorize a fraction in Java, trying to use the programming language capabilities in order to make the best design. So I'm going to explain why I chose this design. This is the best design my group came up with because it uses all the small tasks and accomplishes a complex task called mixed fractions, proper fractions, and reduced integers. The user inputs a numerator or a denominator and and allows the program to do the rest. By allowing the program to subdivide the complex tasks into separate, manageable, more easier tasks, the whole number is displayed next to a fraction. And this is the simplified form of any fraction that has a large numerator or a small denominator that makes it an improper fraction. An improper fraction is defined as a fraction that has a numerator that is too large for the denominator. Thus, this makes it so that when we run mod on the particular fraction, it does not equal 0. The program that I was using um, had a public class called mixed fractions. In the program, we see that when we run it, it outputs a prompt for the user that is the numerator. When the user decides to put a normal numerator like 7 and a larger denominator like 50, it runs the program and it highlights which parts of the program are running. So when it's a proper fraction, it does 7 over 50, leaving the normal fraction normal. But when the fraction is more complex, for example, if we had 140 and the denominator was 19, it says that the fraction is an improper fraction and its mixed fraction is 7 plus 7 over 19. The reason why this works is because the user inputs a numerator and a denominator that are both integers. And when the program takes the user input and constructs a simplified set that represents the original fraction, this implements a, a quick algorithm that handles both the improper and proper fractions. My program uses a while loop because I thought it was the best design choice for this particular problem. The problem asks that we should convert it into a proper fraction or an improper fraction that correctly simplifies the original fraction. If it can be reduced, the program chooses to reduce it. By incrementing doors to the denominator, we can compute the correct numerator that belongs to each separate fraction. The fraction that has a large denominator or a large numerator both are handled through if statements, and each one is nested one over the other, making it the best design choice that allows for 3 separate tasks to run at the same time. My first major step was taking the user input, then running the fraction into separate parts, and finally converting those separate parts into a readable format that allows the user to see their specified output, whether it's a proper fraction or an improper fraction.